Welcome to qnawire.
So now we'll work on problem 46 from chapter 20. In this problem, we're asked, is each of the following substances likely to serve as an oxidant or a reductant? So first we have in part A, cerium 3+. So we can look in Appendix E and find the reduction potential for this cerium. And so what we find from Appendix E is that we have a reduction potential for the cerium 4+ cation, and that's equal to positive 1.61. So this means that cerium 4 is likely to be reduced, which means that cerium 3 is cerium 3 is not likely to act as a reductant because it's cerium 3+ is more favorable than cerium 4. So since it won't be a reductant, it's more likely to act as an oxidant, since it cannot force this reaction to go backwards to the cerium 4+. In part B, we're given calcium solid. And here we get the reduction potential which we get is for calcium 2+, and that's equal to negative 2.87. So that means calcium 2+ does not want to be reduced to neutral calcium. So this means that since it's not going to go to neutral calcium, it's much more favorable to go in the opposite direction. So neutral calcium will act as a reductant, a reducing agent, and give up its electron to become calcium 2+. Part C, we're given ClO3-. So here are the reduction potentials which we could get from the appendix would be ambiguous since there's multiple. This reaction can undergo several reactions. So we can look at the oxidation numbers. So for oxygen, it will be -2, which means that the negative charges from oxygen is -6, which means that our reagent here has to be a +5 to make this negative charge here. So what this means is we have a chlorine with a +5 charge, and we know that chlorine's most favorable oxidation state is -1, so that means it's easily reduced. It's very likely to gain electrons to go to Cl-, so that means it's going to act as an oxidant. In part D, we're given N2O5. We can do the same thing as we did for part C. We have -2 here, which means that this nitrogen is a +5 since we have -10 coming from the oxygen. And the same thing here. Nitrogen normally has a less positive value, so it's more likely to gain electrons. It's easily reduced, which means it's going to take electrons and act as an oxidant.